There are other properties we can use as conversion factors if they're constant for a given material or a given situation. Density is one example. Density for a given material is a constant value at a constant temperature. So it can be used to really convert between mass and volume, two properties you would not think you could relate together. In this case, for copper, the density of copper, you look up in a table, I don't expect you to memorize it, is 8.96 grams per milliliter. Then you can use this to convert from grams of copper to milliliters of copper, or vice versa. You just put in the units first, grams here, milliliters, and then put the number in. Look up in the table, it says 8.96 grams per milliliter. Or to go from volume of copper to mass of copper, just go the opposite direction. We can do the same thing with velocity of a car, an airplane, a bullet, a satellite. If it's traveling at a constant velocity, we can use that to convert between distance and time. See how far a car goes in 2 hours if it's traveling at a constant rate of 20 miles per hour. Then you can do the same type of calculation. So it's not just using constant properties. We can use other relationships in many cases as conversion factors. And we'll do this later in the semester using balanced equations and other properties. So a good example here, if we'll look at another example for density. Density of titanium is 4.5 grams per cubic centimeter. What's the volume of 7.2 grams of titanium? So this is a good sample problem for you to work out yourselves. Suggest you pause, work out yourself, try to get the answer. Then come back here. All right, if you came back and you're getting stuck, I would suggest to get started, this is the value you're starting with. We're starting with 7.2 grams. So write this down first. Then you write your conversion factor, put grams on the bottom, cubic centimeters on the top, and then use that to solve your final answer. And try that and complete the problem. So 7.2 grams, we know grams on the bottom, cubic centimeters on the top, and I got to double check that number, forgot, 4.5, and it's 4.5 grams per centimeter. Now in this case, I'll make sure I got the right sig figs there. Thought I was lazy about that. 4.50. This is 3 sig figs. This is written as 1, but this is really considered the precise value of that relationship. So it's still going to be 3 sig figs for our answer. Again, grams cancel grams. Our answer is going to be in centimeters cubed. Since we're trying to get the volume, that's a good thing. So we get, and same thing here when dividing, we should be getting a number less than 1. We're dividing 7 by 5, basically, or 7 by 4. So a little bit more than a half. I'm sorry, getting a little larger than 1. 1.5 or so. So in this case, actually gives us 1.60 cubic centimeters. And that's it. So pretty easy to use. So as I said earlier, there are some sig figs and conversion factors that are considered exact. 12 inches is a foot. This is precise. Kilometers to millimeters, seconds to hours or to minutes. For many relationships, it often depends on the precision that's listed. 1 liter is 0.264 gallons. This can be listed actually out to more sig figs depending on how precise it's needed, but it's not usually given. But in this case, the 1 doesn't really count for sig figs. That's soon to be precise. It's the decimal value that really determines your sig figs, just because it's kind of redundant, or maybe people are too lazy to write down 1.000 liters equals 0.264 gallons. One weird exception, because this is the way it's defined, is 1 inch is exactly 2.54 centimeters. This was defined precisely, I think 50 or 60 years ago, to have a precise relationship, though apparently in some parts of the United States they use a different definition for some reason. Anyway, that is considered an exact definition though. So there's infinite number of sig figs after that. I will briefly mention temperature scale here. Conversions, these are the conversion factors. If you have to convert from one to the other, between Fahrenheit, I'll actually give you that relationship. The only parts of this I want you to know are boiling point, freezing point for water, in Kelvin and Celsius. Well, Celsius and centigrade, same thing. You should know water freezes at 0 degrees centigrade, boils at 100 degrees. And you should know that in Kelvin, that's 273 and 373 Kelvin respectively. Kelvin is an absolute temperature scale. 0 Kelvin is the coldest you can get. We'll discuss later with thermodynamics, heating and cooling objects. Heat really is a measure of kinetic energy, how fast that atoms and molecules vibrate. You heat something up, they're vibrating faster and faster. You cool something down, they vibrate less and less. So once they stop vibrating, you can't get less than no motion. And that's really why there is a, come back there. There is a 0 degrees Kelvin. That's the coldest you can get. Once you get down to 0, that's it. There's no less than no motion. So temperature is really a measure of the average kinetic energy of the particles, how fast they're moving and vibrating. The faster they vibrate, the warmer the temperature is. So, but that's the only part of this I really want you to get. If I want you to convert from Fahrenheit to Celsius, I'll give you the relationship. If you know this relationship with boiling point, freezing point of water, it's easy to figure out how to convert if you ever need to. So I'd rather you do that than try to memorize add or subtract 273. Always go back to this to double check anyway, because it's easy to get tripped up sometimes. So, all right. And if you have any questions about that, just let me know.